Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, well, welcome everyone. So today we have with us Kris Jenkins, who is a developer advocate at Confluent. Did I get that right, Kris?
You did indeed.
Awesome.
Hi.
So great to have you. But today, maybe we'll get into Kafka, who knows? But what we did want to talk about is Haskell, since I discovered that you are quite the Haskell fan. So, and we have not talked about Haskell. But before we get into that, Bruce, Winter Tech Forum.
It's coming up. You can still
here in Crested View.
You can still show up. I've redone if you want to just show up using the bus in the cheapest way, I've redone the page.
Oh, nice. Has bus transportation information.
Yes, which I've actually taken and I like a lot. I will do it again.
Yeah. So even though Crested Butte is in the middle of nowhere, it's not too hard to get to.
Yeah.
It's possible.
There's various ways to do it.
Yeah. And this morning, as Bruce was pointing out earlier, it was negative 17 Fahrenheit.
In the middle of the night, yes.
Yeah. But I think week after next is not going to be that cold.
Oh, yeah.
It's going to warm up.
By the time we hit March, we tend to have warmer weather. But still, lots of snow this year.
Lots of snow. So more coming next week. So snow should be great for skiing for those who want to do that. Okay, hopefully you all can join us at the Winter Tech Forum. Okay, and Kris, tell us about yourself, but also make sure you tell us about your podcast.
Oh, yes. Never miss a chance to plug that one. So what can I tell you about myself? I got my first computer when I was 10 years old and haven't looked back since. I did a computer science degree and then stuff, and eventually co-founded my own company, Trading Gold.
Whoa.
Was CTO of that for 10 years. Left for a million reasons, but went into contracting. And I can lead into what we're going to talk about because I really got into Lisp. And by that, I really got into Clojure. And I did a contract with a company, weirdest tech stack you've ever heard. They were Clojure script on the front end and Haskell on the back end.
Okay.
And that was my first exposure to industrial Haskell.
And how long ago was that?
That was about 18 months, which for a contract is relatively long.
No, I mean, how long ago did it
let me think. That was maybe 10 years, maybe a bit less.
Okay. So you've been into Haskell for 10 years.
Yeah. I guess I have. Yeah. What fun times.
Nice. Okay, and what's your podcast?
My podcast is Streaming Audio, or search for the Confluent podcast. And we talk mostly about Kafka and the stuff around it. So like event streaming, event systems design, real-time data.
CQRS, all that fun stuff.
Yeah, all those good things.
We did an episode on CQRS and event sourcing with, I think, one of your colleagues.
Who was that?
Anna. Didn't we have Anna on?
Anna McDonald.
Well, she explains Kafka to us.
That's right. Yeah. So that was a fun one. We won't maybe we will rehash some of that or go into some of that, but we so to kick this off with functional programming and Haskell stuff, I have done Scala for quite a long time now, and it was my first real forte into functional programming, and it took a long time for me to kind of get it from a traditional Java background. But now I'm like, I define myself as a functional programming zealot who often has to balance reality and pragmatism with that zealotry. And so I've totally drank the Kool-Aid. I like functional programming. For me is the pinnacle of what I've done in programming for probably like almost 3 decades now or something. I guess I've been programming for like 3 decades. So anyways, love functional programming, but in the world of Scala, there's a number of people who have come from the Haskell world. Most of them have come from the Haskell world into Scala because they wanted a paying job, and apparently that's not as plentiful in the world of Haskell. But
we can talk about that. But
yes, let's talk. Okay, but before we do, I'll finish my little summary here, intro. So Haskell, at least from that side of my experience in Scala, was always seen as like the golden standard for functional programming. If you want to do functional programming, you got to do Haskell. Like it is the way. It is the best there is. So
I'll put in my perspective, which is I'm not sure actually how long I've been struggling with functional programming, but I have learned a ton from it. It is fascinating. I'm struggling mostly with it's like, boy, how do we transition to it? Because it's so different. The kind of thinking that you do is so different from how people are trained.
Yeah.
And
from the imperative.
Imperative,
style.
and then we added the object stuff. And I'm doing a presentation at the upcoming PyCon, and it's called Rethinking Objects. And it's like, let's look, because you've seen a lot of things, probably articles where people come out and they've probably been exposed to functional programming and they go, oh, objects were a mistake and it's all terrible. And when I started digging into those, I started going, well, you haven't really, you've shown some issues, but you haven't really proven it. It's like, because I was hoping, I can just go down this list and say, here's why objects are a failure. And you can't really do that. There are benefits, there are ideas in there. And the idea that functional programming, well, in fact, my friend Bill Venners, he said, well, objects were sort of made up, whereas functional programming was like derived from mathy thinking. And it's like, okay, that's all very interesting, but can we move people into this? Or is this going to be, do we have to have a generation of object-oriented programmers just die off, and then the functional programmers will come along?
That's bleak.
That is bleak. That's a really bleak way of putting it.
Well, historically.
God, well, there's a lot to unpack in what you've just said.
Yeah, let's go.
Let's start with Let's start with Turing completeness. Okay, let's start.
Yeah, let's start there.
People say, one thing you often hear when people are debating programming languages and different styles of programming is they're all basically the same. They're all Turing complete. Programming languages are a question of style. Right? And that's true and completely unuseful, unhelpful, because we don't write programming languages for the sake of the programming power. We write them to make programming easier for us, for humans, right? I think it was Grace Hopper who invented the first high-level programming language, not because she couldn't program in assembly, not because she couldn't do the job in assembly, but because it was too hard. She needed to make life easier, or wanted to.
Yeah.
So what makes life easier in programming languages? And one part is the familiar. If you've been trained in objects, that familiarity has a real value. And thinking in functions is a hard shift to make. I find, people get hung up on the syntax of Lisp or Haskell, but actually once they've got the ideas, the syntax is trivial,
syntax has a huge impact on familiarity.
I have found
but it's very surface.
More I've learned, the more I can look at, because initially when you look at Haskell or a Haskell-like language, I think my first serious one was Elm. It's like so foreign. And then when you go, oh, I see, you're doing this for that reason, or you're doing this for that reason, then it's like, okay, I can look at the syntax and make sense of it.
Yeah, like once you understand the why of currying, it does become easier to accept it and understand, kind of embrace the syntax of it.
And one thing I think is like a telltale sign is once you've embraced currying, it becomes harder to accept languages that don't have it. Like, that's a standard tool that should be everywhere.
Yeah, like expression orientedness.
I
think a really good example of this.
That's annoying.
Yeah,
when you look at languages and you go, why did you bother with statements at all?
Yeah,
what was your? And I'm gonna guess the motivation was, oh well, we didn't want to waste the assembly language instructions. To make it an expression rather
easier
than
to map a statement to the underlying assembly.
Because I keep digging that
assembly
up.
is statement oriented, right?
Yeah.
Yeah.
Yes, exactly.
Yeah.
So
Just a more direct mapping.
It may be that everything started as statements and somebody half introduced functions, right? Look at this. Look at this thing where you can have expressions as well, and they actually just return a value to you magically. You don't have to stick it on the stack and then query the stack as a separate operation.
I would believe that.
Yeah. Yeah, just the evolutionary perspective.
It is.
So, functional programming. Some of the challenge of people adopting it is that there's huge value in familiarity. And is that a good summary of what you're saying?
I think, and I find this like with there's a huge parallel between relational databases and event systems like Kafka. The thing we get hung up on is teaching people the technology, but actually everyone's very good at picking up new technology. We're trained for it. But what's harder is giving them whole new ways of thinking about designing systems. That, I think, is the real challenge.
Yeah.
And specifically for Haskell, I think the big challenge, the absolute core of Haskell that you have to get it, is side effects. You have to understand what a side effect is and why it matters before you're really going to understand why Haskell is trying to be what it is.
Yes.
Yeah. So understanding that kind of deep internal motivation helps you understand why the approach is so different from what you're used to.
Yeah. And why it's a sensible approach. And then you start to want to think in that way, and then you can build systems happily.
Because if you don't understand that, you're just like, this is painful. Why am I doing this?
Right. Okay. So we're now going to use the error monad, and here's how it works. And you're going, this looks harder. This looks more messy. What's the problem with exceptions? Why
can't I just call throw?
Yeah.
Exactly. That worked before, and now you're making this much more complicated. And so if you don't understand that, and my developing theory is that we get early adopters and their motivation is to get somewhere as fast as possible, to kind of, skip over the water like a stone and not go into the, they're trying to get to the end. And so when they explain something, all that intermediate stuff is like, I can make it work. I don't have to really understand it in depth. And so as explainers, they're not doing a good job, and they're not doing what you're saying. They're not going, okay, let's start with why are we doing this? And then when we show you the syntax, you're not going to freak out and go, this is too weird.
Yeah. Yeah. But at the same time, it's a really difficult problem to balance, because you also, in order to get people to that point where they really understand it, you want to get them to have some victory, some sense of accomplishment with it today. Yes. Right. And this is why you mentioned Elm. I really like Elm because it's a really nice, friendly, tries to help you functional programming language with which you can get some interesting, fun results easily. Like you can stick fun stuff on a web page and see the fruits of your labor as you're learning. And that's a nice feature.
Yeah. Yeah. And probably one of the reasons why JavaScript has been so predominant and everyone knows it is because you can just go into your browser, open up the developer console and start writing code and immediately see visual things happening in your browser, and that there's something very satisfying.
Cool. Yeah, we don't really pay enough attention to the onboarding experience for the novice because that's boring. Let's get to the really fun stuff.
Yeah. And the other thing that's great about JavaScript, I'll give it this credit, is it has this deployment model where I can send my source code to my aunt or my cousin who knows nothing about programming, and they can run it.
Yeah.
Because I just stick it in a web page.
Yeah.
And they don't even know they're running a programming language. I don't think any other language has that deployment model.
Right.
It's amazing.
Amazing.
No.
So for Haskell, I have never really done any Haskell except for the Elm, which isn't Haskell, but Elm, but is Haskell-ish, the closest I've gotten. And part of the reason is that I've always looked at Haskell as being for the experts, like the people who like really understand functional programming. And so there's always been this hesitancy for me to get into Haskell just because I'm like, oh, that's for like that's for the pros
and academics.
Yeah, and academics.
Yeah, I think you may be confusing cause and effect, because it's a great training ground for functional programming. Yeah. And if you are a zealot and you really want to get into it, I'd say go to the source, man.
Right, go to the source. Right to Haskell.
Yeah.
Tell us about Haskell. Like what?
How would you describe it?
Yeah, how would you describe it? That's a good question.
Okay. I would describe it as a functional programming language, one of the original ones, that was really concerned with the idea of side effects, right? Maybe we should describe side effects separately, but for now, it's built around the idea that programs shouldn't have unexpected side effects. And so we're going to build a language that eliminates them wherever we can. And where we can't eliminate side effects, we're going to teach the compiler to control their scope. And so you end up with this language where you can say things like, I want to calculate the tax on a sale, right? So that's just multiply this number by that number. That is a pure function, and the compiler can tell me it's a pure function. Now, I want to record the tax collected to the government, and the compiler can say, well, that's a function that needs access to the internet, right? Because it has to talk to the government server. If you imagine a futuristic government that can actually do this in real time. Now, imagine the network goes down. The compiler can now say, well, that first bit of code it won't fail because it doesn't need the network, and I can prove that at compile time. But the other bit of code might fail because it has the side effect of needing network access.
Yeah.
And you can do that scales out into the whole language. Like if you're a Java person, right, you can have the compiler track which bits of code expect to have access to logging and which don't. Now, imagine you're a Java programmer waking up one day to find there's a massive security hole in the most popular logging framework.
That would never happen.
Hypothetically.
Okay.
Haskell could say, well, all this code can't possibly be affected because if it compiles, I can guarantee you it doesn't use logging. All this code, it potentially is affected because I know it uses logging, and you've almost got like built-in security sandboxes across your whole code base and built-in impact sites across your whole code base.
Okay, so the idea is not just the effect, but being able to, I don't know, have a list of them and go, okay, I know if the internet is working, this might work, and if my database server is working, then this might work. And so that you can somehow reason about the individual effects?
Yeah, I'd say fundamentally it's about saying side effects are inherently unpredictable. They're what make code unreliable because they are hidden behavior. The side effect of needing the network makes your code unpredictable in the face of network errors. The side effect of needing a database makes your code unpredictable in the event that your database goes down. And so having recognized that side effects complicate programming, the whole language is built around trying to eliminate or control side effects of any kind, and gives you a set of tools for dealing with that.
Giving you the set of tools to deal with them, I think, is key, because in most languages that don't do this, it is the norm to just ignore the things that can go wrong.
Yeah.
Well, the programmer handles those.
Yeah.
and you may only actually deal with the things that can go wrong once they've actually gone wrong and you've gotten the error in your production system.
And there's instructions in the documentation that says, okay, so the programmer, if this fails, the programmer is responsible for handling it, and these are all the things that could go wrong. Have a good time.
Yeah. And we end up, because of that, I can name check you here, because of that, we end up with a lot of programming that just worries about the happy path. And so it becomes great if everything's working, which we know as programmers is rare.
Yeah.
And it all falls apart if things break. Whereas Haskell is like this wonderful, horrible thing where it forces you to deal with your errors before it will even compile.
Yeah.
Which is a horrible experience when it's thrust in your face the first time you start learning. But as you get used to it, it's like, yeah, if something's going to go wrong, I want to know now when I'm programming, not next week once it's in production.
Exactly.
It's a really nice feature.
Yeah.
Yeah, but that's only if you write code that fails.
Yeah, and that's the other option. Right,
Could we possibly hear a dedicated podcast on how not to do that?
That's
Yeah.
It's going to be a long
Who
one.
would we interview?
Yeah.
Okay, so I want to know. You said okay. So we got the side effects. We want to know about them, and we want to control them. So what does this control mean?
So the control is that Haskell has this mechanism for baking side effects into the type system in a way that if your code uses networking, that's baked into the type signature. Right? And if your code uses something that uses networking, that gets baked up into your type signature all the way up the tree. So you cannot avoid accepting, noticing, dealing with the fact that you are now subject to the side effect of networking.
Yeah.
And it does that primarily through the word I was going to try and avoid saying, but you can't discuss Haskell for an hour without saying it, through monads.
Yeah.
But I think people often confuse what monads are. Haskell is trying to get rid of side effects, and then it realized early in its inception that monads were a great way of making them easy to program with. So we can
monads became the tool to do what you're talking about, which is the controlling the side effects. The monad is the tool to make that easy from the programmer. Easier.
Yeah. It's almost a developer experience tool for making tracking side effects pleasant.
Okay, so you seem to be somebody who thinks about how to describe things. So do it. Tell us what you think a monad is.
Okay. So what's the best way to describe this? There are lots of ways, and I could put on a mathematician's hat and try and describe it to you that way.
You could put on the Chipotle burrito hat and try that way too.
Yeah. But what monads are a way of saying, I've got this context in which we could access the network, right? And take an example of running 2 HTTP requests, right? That's obviously got the side effect of networking. So I need to deal with the fact that either of those requests may fail. If you do that in Go, what you'll have to do is, if you're being a good programmer, good responsible programmer, you'll make the first.
But that's
call.
optional.
That's optional. Sadly,
optional in Go.
I'm sure all the listeners to this podcast are good responsible programmers, obviously.
Yeah.
In Go, you call the function and then you have to check the error return value, and it's on you every time to check it, right? In Haskell, what you can do in other languages is pretend there are no errors, and that's bad. In Haskell, a monad lets you write code that pretends there's no errors within the context of that monad, groups them all up, anything that could possibly go wrong, and lets you deal with it outside. So you end up with this sandbox where you can say, okay, I've got this thing that has the side effect of networking. I'm going inside that sandbox and I'm going to pretend it doesn't happen. And I can just do regular programming. I do a get, I get a result, I do another get, I get another result, I do something with it. And then when I come outside of that sandbox, now it's on me to deal with that error that either of those requests could have gone wrong.
But I would argue that you're in the sandbox, you're just programming along, and the sandbox is capturing that error information. And then when you return from your function,
when you step outside of the sandbox,
that package is returned, which includes your result information and all of the potential error stuff that goes wrong. And the package
that would be an applicative.
The package is the monad.
The package is the monad, yeah. You could use package instead of sandbox, and I think it ends up being as roughly the same thing.
Mm-hmm.
And then you could
I'm saying that the sandbox is what returns the package. It collects the information and creates and returns the package.
Handles giving you that result out of it. Yeah, that's fair. That's fair. And then you could say, well, why can't I just have try and catch and throw, right? Well, you can, but then you say, okay, let me think of another side effect. I've got this data that may or may not exist, right? So you have this API called option, probably, in your programming language, and that lets you deal with all these different... it lets you deal with the side effect of may not exist. And you've got all this separate syntax and all these separate API methods for dealing with the side effect of may not exist. And in Haskell, we just say, we don't need a separate API. We have one API for monads, and that handles network exceptions, the side effect that things may not exist. It handles logging. It handles connecting to a database. There's one universal abstraction for the side effect of. And that's everywhere in programming. Every time you write a non-pure function, it's there.
Does Haskell then, does the language directly support all of this stuff?
Yeah.
Okay.
Yeah, and has lots of them out of the box, but has a core infrastructure for saying, I'd like to use a new side effect you haven't thought of and make it look transparently available to the language as though it were anything else.
And what is it used to do that additional transparency? Is that like
monad transformers type classes?
Yeah, right.
You define your own monad with your own rules, which isn't as hard as it sounds. And then if you've done that, you get access to do notation, which is this syntactic sugar that makes working with monads
like
easy.
For comprehensions in Scala.
Yeah, a lot like that.
Mm-hmm.
In fact,
so the language just, if you define the monad, the language just magically sees it and incorporates it?
Yeah. You're basically implementing like an interface, you'd call it in Java, the monad interface. And it has some rules to help you make sure you implement it right. And sometimes people call them monad laws, and people get scared by that, but it's just rules on how to get it right.
Yeah.
And then you can just use it like you would any other monad.
Yeah.
Okay.
So side effects, that sounds like one of the kind of core motivating features of Haskell, and a reason that so many people are attracted to it is that isolation, the ability to be forced to deal with the things that can go wrong at compile time rather than at runtime.
Yeah, get your problems today instead of tomorrow, which is a mixed blessing, but I like
That's right. Yeah. I mean, sometimes it seems so painful to have to deal with my problems today. I would like to sometimes just kick that can down the road, but
welcome to the therapy podcast.
That's right. Exactly.
Well, and there is the Go language if that's your orientation.
There you go. I think there's some other interesting pieces to Haskell that I hear talked about. One of those is type classes. Do you want to go into type classes?
Yeah. Now, some people will shoot me for saying this, but I don't think spiritually at least, they're not that different from interfaces. You define an API called a type class, and then you can implement different instances of it. They're a bit less coupled to the... There's interfaces in Java, say, always feel a lot more tightly coupled to the specific objects, whereas type classes in Haskell, they feel a bit more standalone, right? You just say the code for someone else's data structure.
Yeah.
But
is
essentially,
there inheritance in Haskell?
Or
do people accomplish that kind of thing through type classes?
So type classes can inherit. You can say this is a new interface that extends the previous interface.
Okay.
But there isn't.
Is there implementation inheritance?
No, because you wouldn't have objects. So you can have a data structure that has a type class implemented on it. So imagine an array, and you implement an interface for arrays. Right. Now you can have... The closest you get to inheritance is you have a new data structure which has arrays in it, and you implement that same interface. Yeah, it really is composition.
So you could compose a new data structure that's array plus a type class or something like that.
But inheritance ultimately is just fancy composition.
Yeah. Or dangerous composition, depending on your...
So, but is type classes generally the way to kind of add behavior to data structures, or is it
generally? No, generally functions perform behaviors on data structures.
Okay.
Where type classes come in is where you want to have the similar behavior or the same external behavior for many different data types.
Right. Okay.
So you might want to implement. Yeah. So you might want to implement size on lists and arrays and vectors and maps, right? So there'll be a type class,
right?
On the foo. Yeah, exactly. Size of user, if that's not a personal question.
There you go. And so the type class, you would just create a type class for size of person, and that would allow you to add that behavior.
And then someone can extend their data structure, implement your interface as well.
I feel like we've debated if type classes are ad hoc polymorphism or if that's something else.
Well, my research said ad hoc polymorphism is function overloading, but
so I'm not sure on the polymorphism category that.
No, I'm still. I've used the term for so many years, and then I finally started asking, well, what is polymorphism, and realized that, I had gotten myself into a little cul-de-sac about, because I started with it in terms of inheritance polymorphism, and it's like it was hard to expand. And then when you see it as, you're actually applying the quote unquote same function to different types, then it's like, I see, that's different. But it does seem like that's a little bit of what we're doing here.
Yeah. We could, it depends how deep you want to go down the rabbit hole, but we can now talk about higher kinded polymorphism.
Yes.
Which sure, why not? I don't know what that is.
Well, so let me see if I can explain this without the use of diagrams, which could be tricky, but this is radio, so we'll give it a go. So you could imagine you have a function that doubles things, right? So if you give it an integer, it doubles it, and if you give it a string, it repeats it. Now you've got a list of things, list of integers or a list of strings. You probably have a map function that will let you call double on a list of anything, right? As long as it can be doubled, you can call double on a list of things and it will double all of them. Now, could you extend map so that it will that it will apply to double on any collection of any kind? Not just lists, but also arrays, vectors, maps, users. Can you define a function that, instead of not caring what the contained type is, doesn't actually care what the container is?
Yeah.
Now, if you do that and you try and write it down, let's say in Java syntax, the first one will be list angle brackets int.
Generic.
The second version is list angle brackets e. But for the third version, we need a variable for the collection. So we need like C angle brackets E. What does that look like? And what you actually end up with, it's a polymorphism of a higher kind.
Yeah. Okay. Yeah.
And that's a head trip, and it takes a while to really grok when you're programming it, but it's incredibly powerful, and I don't think many other languages have it.
Haskell does,
and Scala does, and the places where Scala has been influenced by Haskell use this concept heavily, and it's been one of the things that's kind of made me a little hesitant to go into Haskell, is because I'm like, it's a head trip, like because then all of a sudden you're not thinking about tangible things anymore. You're thinking about generic things kind of everywhere. You're like, all of your functions don't take and return things; they return the higher kinded things.
Yeah, they just return generic shapes. But where that gets interesting is you can do things like, because the function you're calling doesn't care what collection you pass it, right? You could be passing it an array of something or a list of something. It doesn't care as long as it's mappable.
Yeah.
So you end up with this situation where you as the caller can influence what type of collection you get back, for instance. So you can, I think the clearest example of this is when you have like parsing libraries, and in many languages, you'll get parse int and parse string and parse float, right?
Yeah.
And what it would be nice if you could just call a generic parse function, and the return type you're expecting determines what function actually gets called under the hood. If you could have return, if you could, as the caller, had return type polymorphism, then your DX again would be much improved, because you could just say parse it and give me an integer back. It's up to you how. And that simplifies a lot of code like JSON parsing type stuff.
So just backing up a little, when you were saying, okay, higher kinded types on the container type itself, it occurs to me that the idea of an iterator is the way that has been done. So it's like,
we picked a base type that
we said, okay, all I want to do is know that I can move through this container. So I'll have this intermediate type that does that for me. But it sounds like you're saying, oh, well, Haskell can do that without having to introduce an iterator.
Yeah. And I'd also say, now correct me if I'm wrong, my Java is like, my modern Java is a little patchy. But I think there's now iterator and iteratable since like 1.7, sure. 1.8.
Yeah.
What if you, and you have to know which one you're calling, and you have to know which APIs let you get through to the right one you want. Why can't I, as the caller, just say, I'm going to treat the thing you return like it's an iterator here? So it's up to you to make that happen.
Mm-hmm.
Yeah.
I would like, sure, for implementation reasons, you need to have a difference, but just give me the one I'm asking for back, just magically.
Yeah.
And if it doesn't exist, the compiler will tell you.
Yeah, but as long as someone's implemented that bridge, they do it once and for all.
So you have to have the type class to do this, or
so you would have to have the type class implementation, but it's the mechanism of higher kinded polymorphism that makes that all work transparently.
Yeah.
So the compiler will run off and say, this is how I build the bridge from what you're expecting to the actual function.
Yeah.
And the reason means you end up implementing that once.
Yeah.
And for all.
And the reason why it's higher kinded is because you don't have to have the concrete type on the outer scope. The like outer type is generic essentially.
Yeah, and we're used to having genericity.
Genericity.
We're used to having a variable in the concrete, like the int, but we're not used to having like a C of E, a collection of elements, right? You actually need two types to make that concrete. You need the int and the list. So what is that C? It's something that needs a type to become something that needs a type to become an actual concrete type. And that's why it's higher kinded. You're sort of climbing that ladder of abstraction.
And this can just go further down the chain because the thing inside could also be a higher kinded type, right?
Yeah.
It represents a hierarchy of types within other types of other types.
Guess
and
that people who understand higher kinded types would have a lot easier time using Java generics or generics in any language because they'd have that mental mindset.
I would definitely say that's true. Possibly find it a bit constraining though.
Oh, I'm sure.
Yeah, but
it's generics. I
think it was
difficult.
Was it Philip Wadler's talk at Strange Loop or something a long time ago where he talked about how your functions should be as generic as you can possibly make them, and because that the constraints that imposes actually has a lot of value in that. If you look at a function that takes an A and returns an A, if you assume that you're not in Java and that that A has a toString and a whatever else, so excluding that, there is only one possible implementation of that function that takes an A and returns an A. And so you can reason about the implementation of functions more easily the more generic their parameters and return values are.
The Red Book talks about that too.
Yeah, I think that was Philip Wadler's Theorems for Free paper that first talked about that.
Yeah,
like,
and then a corresponding talk that I think maybe with the same name at Strange Loop.
Yeah. I mean, Phil Wadler is one of the founding fathers of Haskell and discovered a lot of really great stuff like that. Like you can at an academic level reason a lot about a Haskell function just from looking at the type signature. But actually, as a jobbing programmer, you get a heck of a lot of information from a type signature in Haskell. Without looking at any of the code, you can learn a heck of a lot. And that's why I think sometimes, to a beginner, Haskell documentation looks a bit thin, because these type signatures are so semantically dense. They say a heck of a lot to you.
And if you're not used to that
back to the familiarity piece,
intimidating. Yeah, since Python has adopted, type hints they call, but basically allows you to have type signatures. It helps dramatically in understanding the function, or just even knowing, this is a string that goes in and an int that comes out. I know something already now that I wouldn't have known without that type signature.
Yeah. And
so
you
then
can
Haskell
get things
also
like
brings into this the pureness. So from the type signature, you also know if something has side effects or not. And so then you can add kind of more reasoning to the behavior of a particular function based on that.
Where does the behavior show up in the type signature, or the side effects, or whatever?
You can get, so I'll give you a couple of examples. You can get a function that takes a purchase total. The type signature will say, I take a purchase total and a sales tax rate, and return a IRS acknowledgement ID in the context of network access. I know a heck of a lot about that function, right?
Yeah.
I know something about how it fails. I know how to make it work. I know what I'll get back. That's a very dense piece of information.
I get this thing back that's the IRS certificate in the context of accessing the internet. Now, is that in the monad returned? Is that where you see that side effect?
Yeah, you would see that written out pretty much as I said it in the type signature, which is like a one-line thing above the function. And that saying, once you give me these two arguments, then I'm a network monad whose result is an IRS ID.
Okay, but you said in the type signature. Like where so
in the type signature, as in that line of code that sits above the function.
Yes. Yeah. Where in the type signature? In the return type? Is that where you see the side effect?
Yeah. Okay. The side effect is in the last thing in the piece of code you write.
What it returns.
Okay.
Yeah. Okay. So it looks like the return type.
I'm my highest amount of exposure to monads is really in Zio, and so I'm trying to map this Scala's Zio, and that that fits. They put it inside the monad that is returned by the function. They put in all the side effects.
Yeah.
Okay.
Yeah.
And
so it
then
sounds kind of similar, and that the side effect contexts are part of the monad that gets returned or somehow expressed together.
And then you get things like just to give you another example, you get type signatures like, I take a list of A and I return a list of A, provided I can call double on A. Give me any A that I can call the double function on.
So that provided is your type class.
Yeah. So you have things called type class constraints that say, I don't care what you give me as long as I can call this interface on it.
Yeah.
So type classes sound really fundamental to Haskell.
Yeah. As soon as you want to start implementing the same behavior for lots of different types of data, you're into type classes.
Okay.
That was helpful. What else about Haskell is kind of like headline features for the language, or ways that you use it, or motivations?
So there's no variables.
No, I think one thing I should probably say before we finish off, because the higher kind of type stuff is like, it can seem like astronauty stuff, right? Like But the practical advantage of it is when you start writing code, when you're a beginner, you write the function that says, I take a list of ints and I can double them, right? And then as you get slightly smarter with it, you realize, actually, I don't need to be so specific. I can make my code a lot more useful by saying, I don't need ints. I'll take anything you can double. And then one day the penny drops that actually you're being too specific about lists as well. And you could make this function more useful for every type of container just by using another variable.
Yeah.
And it's like your code becomes much more useful to the people calling it just by you being less specific, by you putting fewer constraints on the caller.
Seems like a dream for library authors and then users, is because there's so much more expression in a library for what is needed, what is returned, the behaviors, the context, like all, like, I don't know. It's just like in typical OO, there's really only one thing you can express is I have these methods, right? You can construct me and call these methods,
and the methods are specific to that particular data structure and attached to it.
Yeah.
One place I think it shows up is if you've ever called, I mean, you must have done this in Java. You like call, you've got a list and you want to get to a list at the end, but you have to convert it to an array because the library author expects an array. And then at some point you switch it through a map to get back out to an array, which you convert back to the list. And finally you're back where you wanted. That kind of dance doesn't really exist in Haskell.
Yeah.
Because it gets implemented by the library author once, if they even need to care.
Yeah. So code reuse could be argued as a big value of functional programming, but is there a, if you were to say to somebody, here's the one most compelling reason to use functional programming, would it be code reuse? Would it be like, we've mastered the code reuse thing?
I mean, it depends who I'm talking to. If I was talking to someone like me, I'd just say it's so flipping interesting. That's my headline. Well, but practically, it's not so much. It is code reuse, but it's more doing more with less. Getting behaviors for free. I sometimes explain things with the contrast. So if I pick on Go, without generics, you end up writing the same boilerplate code for particular data types over and over again, and the language ought to give you that for free. And Haskell gives you a lot of stuff for free as a user, as a library author, and sooner or later in your own project, you're both, because you're writing functions that you're calling.
Yeah.
Right. Mm-hmm. So even in a small project, you are both a caller of a library that you've made, and the author of the library. If you can get stuff for free, that's really cool.
Yeah.
I think the headline thing for a practical working programmer is your code is much more reliable when it ships, because you get more of your errors today rather than when they're seen by QA or CI or, God forbid, your user, and they come back on an email report. If I'm going to have problems as a programmer, if there are problems with the quality of my code, I'd rather know today, and I'd rather know before anyone else finds out. That's the selling point.
This is exactly kind of my journey of programming. Is I wrote a lot of bad code that kept me up at night, fixing production bugs, and now I don't know if I'm older and wiser or just lazier, more tired maybe, but I now want to try to do that stuff up front so that I'm not woken up or having to deal with production.
You have children to wake you up now.
That's right.
You don't need anything else.
Before children, my programs were my children, and they kept me up at night and had to feed them regularly, that sort of thing.
Now with children, your problems come right at the last minute because they're late binding.
That's right.
Mm-hmm. Well, okay, so you said your first experience with Haskell was it was being used on the back end on a server, right?
Yeah.
So is that where you would say, okay, here's the most compelling place to be using this? Or, I mean, like, what if I wanted to create a Windows command line program?
I mean, you can do that in Haskell. And there are some quite nice libraries for that kind of command line option parsing, which I've used. I wish I could think of the name of the one I've used a lot, but I can't. It's not coming to me. Any kind of, like, your general purpose server-side language is a great place to start. If I were doing it in the front end, if I'm getting started, I'd probably look at Elm, because it will help to teach you all the same principles.
Yeah.
Right. And does Haskell create like a standalone executable, or does it require a virtual machine or something?
No, you can create native binaries.
Okay.
And I haven't used it in Anger, but I know they've been recently working on much better ARM support, so you can do it on M1 Macs and stuff like that.
Is there a Haskell that runs on the JVM?
There are a couple. One of them is called Freggy, which I've never really used. So there are Etta is the other one.
Libraries.
Yeah. I've always ended up scurrying back to Haskell, honestly. If you told me there was a great Haskell JVM, I'd love you forever.
Okay.
In Haskell, the general runtime is what, GHC or something, I think I've heard?
Yeah.
So
GHC is both the compiler and provides a runtime with lots of really cool features, like great threading model for concurrency, software transactional memory. I could buzzword you about it, but yeah, it's cool. And it's a pretty fast compiler. Could be faster, but that's true of every large project's compiler.
Yeah.
And yeah, it compiles to back-end binary on whatever you're using. I'm not quite. There used to be a compiles to JavaScript, and I'm not quite sure of the state of that at the moment. But it's not impossible to compile it to WASM.
Are there like web frameworks that are commonly?
Yeah. I mean, there's all the usual stuff you'd expect. Okay. So there are several web frameworks. My one of choice is probably called Servant.
Okay.
Which I find really nice. It makes it once you get used to it, it makes it very easy to write web servers and clients that connect to REST APIs. Just by defining a REST API as a type and then having type classes that turn that into backend code or client code or Swagger documentation.
The Swagger piece too with your type class. That's clever.
Yeah, that's a very nice library. There are implementations for just about connecting to just about every database you can think of, including Kafka. Put the occasional plugin for Kafka.
Nice.
Yeah.
One of the things that I feel like I've seen from the world of Haskell is heavy use of operators. Is that correct? Like, I feel like there's even a search engine where you can like go search for a given operator and.
Oh yeah. So there are. You can do that. I prefer not to. So like, there's a package called Lens, which goes a bit crazy with custom glyph operators and sometimes looks a bit like Perl to me. And when I've worked on Haskell projects, I've had a rule that we don't use those operators, but you can. I just don't think they help readability, and they don't actually save you much typing either in the long run.
Does this come from some of the kind of mathy orientation of Haskell that people like operators in math or something?
Can I tell you my terrible theory?
Yes.
I think it comes from people that can't type properly. The hunt and peckers. It's awful, but I think those people are like, oh, this is only 3 characters, so that's a real saving.
So are people like usually using VI or Emacs and they're not using an IDE that's like auto-completing stuff for them?
So I have used VS Code, if that's your poison. I do know a lot of Haskell programmers that use VI or Emacs or NVim. Yeah. But you're not tied to it.
Yeah, maybe that is a correct theory that those operators are a little easier to type when you don't have the assistance of a IDE.
So it's well, I'm going to defend Emacs and Vim. They both have great LSP plugins these days.
Yes.
So autocomplete is a thing there too.
What year was Haskell? Did it show up?
I'm going to risk dating. I'm going to absolutely date myself here. I remember being taught Haskell in '97 by Professor Graham Hutton. If you look into Haskell books, you'll probably find his one pretty quickly. And that was '97, and Haskell was at the point there where you could teach a bunch of university students. But I distinctly remember him apologizing because they hadn't discovered monads at that point, and he was apologizing that they didn't have a principled way to deal with the side effect of printing to the screen.
That would be embarrassing, yes. Yeah. So what would you say is the easiest way for, beginners to start digging into Haskell if they want to?
So I think you've got two paths. If you want to go straight to Haskell, there's a tool called Stack, which is like a build tool, package manager, project creator, all in one, which is really nice. It's easy to get started with, and it will take you all the way up to like production projects. I learned from a book called Learn You a Haskell for Great Good, which I really enjoyed. And I recommend that to anyone. The other alternative route is you could look into Elm, which doesn't do everything that Haskell does, but it has all the big meaty concepts. Like it has the fundamental concepts.
But does not have type classes.
It doesn't have type classes.
There's a lot of
it does have
around.
A couple of built-in type classes, but it doesn't have user-defined ones.
Okay.
It doesn't have higher kind of types, but it does have this idea of controlling
Haskell. It's Haskell minus, so it's maybe a good smaller surface area to start with.
Yeah, and the main thing about Elm is it's absolutely best of breed in compiler assistance for not just throwing up errors, but telling you,
really
teaching you to understand what the error means.
Helping you solve it.
Yeah, so it's like, the way to climb a cliff is to cut stairs into it.
Yeah,
it's a bit like that.
Yeah. No, I've been very impressed with Elm's error handling, and I know they spent a lot of time on it.
And it's a fun language.
Have their time traveling debugger.
Yeah. And I've built, I've built production projects in Elm front ends, and it's really nice. It scales up really well.
Yeah.
Another thing we haven't talked about, which is true of any good compiler, is you get this whole system-wide integration check, right? When you compile a code base, you are checking if every place this function gets called by anyone in the whole code base, we've at least checked that the types line up, right? Yeah. So we have a basic integration test that's built into the language. Now, if you add that to a language that has a really sophisticated type system that lets you say sophisticated things like, I take these specific kinds of things in the presence of networks, right? You increase that from being a basic check to being actually quite a sophisticated, useful check that covers your entire code base without writing a single unit test.
Yeah.
It's really cool.
Another great Strange Loop talk was Paul Snively and Amanda's talk on types, not tests.
Yes. Yes.
Delightful and definitely in line with this. There's a third path to learning Haskell, which is to read the Category Theory for Programmers book.
I'm not sure.
I had to fit category theory somewhere into this.
Yeah, we've barely mentioned it.
Yeah. Which I actually did start doing. Not that, I didn't read the Haskell one because someone forked it and created a Scala version of that book. But actually, I like math. And I don't know much about category theory. And so I wanted to learn about category theory. And it was actually a really good way to learn about category theory. And I haven't finished it yet. But I for me, it was actually, and I did read some of the Haskell parts of that book, and it was helpful to learn Haskell syntax and how it correlated to category theory.
Yeah, I think it would be useful to know in a way that you could say, okay, I understand why some people go, oh, well, you have to understand category theory before you can do any of this stuff. But can I not, can I explain it in a way that does not do that? But to do that, you often have to know a lot more.
Yeah.
I have, let's see, one other question, observation, or whatever was, so we interviewed Richard Feldman, who's creating the Rock language, ROQ,
ROC.
ROC. Oh, it's ROC. Yes. Yeah. Okay. So he's creating the rock language. And one of the decisions he made in that was that he didn't currying. And that was
not need. He didn't want currying because in teaching Elm, one of the common stumbling blocks that people had learning Elm was currying, and so he decided that it was too big of a stumbling block for him to want to include in rock,
and that he could live without it.
That
I found
interesting. I've actually argued with Richard in the bar after a conference about this.
I want to be a fly on the wall.
I come down on the other side of the argument. I think if something's really useful and where we should be going as programmers, then we don't throw it away. We figure out how better to explain it to people. And I would fall on the keep the useful tool, teach it better side of the argument.
Yeah, I mean, one of the things I really like about Scala is that there's so many amazing tools in the language, and I think probably Haskell is in that same boat. Like, there's as a Scala professional expert, I think I would probably say, like, I know how to wield many of these different tools now, but it is very daunting to a beginner who has this massive surface area that they need to dive into. And I think probably for Rock, he was trying to keep the surface area smaller so that it was easier to learn. But then you can go so far as like Go. We've been picking on Go. So Go, the surface area is so small that when I've done Go programming, I'm like, oh, I just wish I had this other tool or this other tool. Like I feel very like I'm missing all these
the language
things.
Is simple. So
well, you end up just having to recreate those tools or some way to.
But it's simple. So
I think one thing we often forget, which like professional user interface designers understand, but programmers forget, is that when we're trying to make things easy, there's a huge difference between making something easy for a casual user or a first-time user and making it easy for someone that's going to use this tool for 40 hours a week, every week, for the foreseeable part of their career.
Yep, very good distinction.
I remember Bjarne Strustrup saying, when we were on the standards committee, saying that because when generics were being introduced, and they seemed like, oh, this is or templates, he said, okay, we're going to make a distinction here between the user programmer, a person who's a programmer who's a user, and a person who's a programmer who is a library creator. So there's the library users and the library creators. The library creators have to know a bunch more in order to create these components that are then easily used by the consumer of the library components.
I think that relates to, I mean, here's a warning for people getting to the edge of the Haskell cliff. There are so many interesting pieces of brain food in Haskell. There's a lot you can learn, a lot you can use, and if you get into it, there's loads of stuff that's exciting, but you don't need to throw every feature into every project. And the core ideas of immutability and side effect tracking boring Haskell will get you such a long way. And I find it so much a nicer programming experience than any other language. You don't need to go into like astronaut stuff to get a lot of the value.
It's like you can choose not to use currying in your code base. I think part of the challenge
wash your mouth out, but I get your point.
Yeah.
Yeah, the idea that, okay, for the new programmer, there is some kind of, subset that they can use and be effective with, and then slowly acquire some of these other features, and that might make their code more sophisticated. But there isn't before you do anything, you have to understand category theory and how it applies. And it's like, okay, well, that's going to make it really inaccessible for a lot of people. I don't know, several years ago, I was revisiting Java generics, and I came across this study that had been done, and they found that something like 98% of all uses of generics were string. everybody was just using list of string, string. Everything is
genericized when most of the implementations.
And what does that tell you? I mean, we understand, okay, there are things that you can do, but it's like, does that mean that the vast majority of programmers are just doing string processing because they can get their heads around it? I mean, that's a little scary to think about.
Yeah. Yeah. Oh, God. I suspect there are. I mean, I know of a company local to me that uses TCL, and that's a language where everything's a string, right? So we're definitely not immune as an industry to string-based programming.
Mm-hmm.
Yeah.
Mm-hmm.
But we've got to try for the future, right? We've got to try for that better future.
Oh, well, yes. That's what I mean. The semi-ironic meaning of the name of the podcast is, yes, we know when you say the happy path, you're ignoring all the problems. And yet we really do ultimately want to go and achieve a happier path anyway, where you can not have to be holding all of that stuff in your own head.
Convergence of easy and happy path.
Mm-hmm.
And
reliable.
Yeah, exactly. Hopefully things like Haskell make it easier to program the happy path in a way that is reliable.
Mm-hmm.
Yeah, I think that's true. And I'll throw in a bit of some advice at the end. It really helps if you're learning Haskell to find someone that knows it. Because it's such an alien language, it can really help to have an expert say, that thing you're not getting, here's an explanation you can understand, right? Here's a tailor-made piece of education for that stumbling block you've got.
And there's probably
that's true for anything.
Yeah. That's true. That is true.
That's true for all learning.
Yeah.
There's probably good Haskell communities like on Slack or chat channels of some sort where people can engage. And
in this post-COVID world, there are good meetups for it.
Yeah. Nice. Well, good. This has been super helpful. Maybe at Winter Tech Forum, we'll actually write some Haskell.
Yeah.
It'd be a fun way to dive in.
Sure.
Because then we could do it together. And I'm sure that someone will show up that knows Haskell. So it's happened. Chris Phillips.
The trick is getting them to admit it in public.
Yeah.
Well, I think in our community, that's not so hard. People wouldn't be, knowing multiple languages is a good thing.
Well, thank you, Chris. This has been super helpful.
And absolute pleasure.